Hello, welcome to Operations Management. In this lecture, I will talk about cost volume analysis. So we will be using the formula of a profit. P is equal to R times Q minus fixed cost plus variable cost times Q. So this is the only formula we will be using, and we will manipulate this formula as required. So P is the profit, R is the revenue per unit of products sold, Q is the quantity of products sold, so it's a quantity, FC is the fixed cost, and VC is the variable cost. And then we have Q, which is again the quantity sold. So we will use this formula and manipulate as we require. I will try to solve a problem on this. So here is our question. The owner of old-fashioned berry pies is contemplating a new line of pies which will require leasing new equipment for a monthly payment of $6,000. Variable costs would be $2 per pie, and pies would retail for $7 each. And they're asking us several questions. The first question is how many pies would be sold in order to break even. So our formula, again, if you see, it's profit is equal to revenue per unit multiplied by the quantity minus the fixed cost plus the variable cost multiplied by the quantity of products sold. So here the revenue R is, it sells for $7, so that's $7 per unit, as it says $7 each. And then our fixed cost would be a monthly payment of $6,000 for leasing the equipment, so that would be our fixed cost. The variable cost would be $2 per pie, so that is per unit. So once we have this, the A question, how many would it be sold in order to break even? So for any business to break even, the break even point is profit is equal to 0. So that's the break even point. So in this case, our profit is, they're asking us how many pies, so they're asking us to determine the quantity for A. So what would be the quantity for profit is equal to 0? So the profit formula here, if you see, we will manipulate it to R is 7Q minus fixed cost is 6,000 plus variable cost is 2Q. So this expression should be equal to 0. So now we have to determine what would be our Q. So 7Q minus 6,000. So if I remove the parenthesis, this will be minus 2Q is equal to 0. And then 7Q minus 2Q is 5Q minus 6,000, is equal to 0. So this will be 5Q is equal to 6000. So Q will be 6000 divided by 5, which is going to give us 1200 pies. So they have to sell 500 pies per month to break even. So now I will try to solve B. So the question B is, what would be the profit if 1000 pies are made and sold? So we are trying to again use the same formula. We will look at if we sell 1000 units. So P is equal to, again our formula, 7Q minus fixed cost is 6000 plus 2Q. So this is our profit expression. So Q is now 1000. So what would be the profit if we put 1000? So this will be, profit is equal to 7 multiplied by 1000 minus 6000 plus 2 multiplied by 1000. So if you calculate this, you will get around, so this is 7000 minus 6000 minus, if I open up the parenthesis, so this is going to be 7000 minus 8000, which is negative 1000. So we will make a loss of $1000 if we sell 1000 products. So that's B. So now the C part of the question they are asking us is how many pies must be sold to realize a profit of 4000. So I will do C in the next page. So our same formula, profit is equal to RQ minus fixed cost plus variable cost multiplied by Q. So profit is equal to R is 7 and Q is quantity Q minus fixed cost is 6000 plus variable cost is 2Q. So this will be our formula. So they're asking us how many units we need to sell, how many pies. That means we have to determine Q here to gain a profit of 4000. So that means this is 4000. So how many I wanted to determine what would be my Q. So that's 7Q minus 6000. If I open up the parenthesis, it will be minus 2Q. So 4000 is equal to 5Q minus 6000. If this 6000 goes that side, this becomes 10,000 is equal to 5Q. I divide by 5 on both sides. I get Q is equal to 10,000 divided by 5, which is going to give me 2000 units. So if I sell 2000 units, I will get a profit of $4000. So that is what C is. Now part D, they are saying if 2000 can be sold and a profit of 5000 is the target, then what price should be charged per pie? So again we are using the same formula. P is equal to RQ minus fixed cost plus variable cost times Q. So the profit they wanted to get is in the question $5,000. So $5,000, and then they wanted to determine the revenue. So that is what price should be charged per pie. So that's revenue per unit. So we wanted to determine R, and Q is they are saying 2000 can be sold, so Q would be 2000 and our fixed cost would be the same, which is 6000 plus variable cost would be same 2 and the quantity is 2000. So now we can determine R from this expression. So 5000 is equal to 2000 R minus this is 6000 plus 4000 is 10,000. So if this 10,000 goes this side, it becomes positive. So that's 5,000 plus 10,000. It's going to give us 15,000 is equal to 2000 R. So dividing both sides by 2000, we'll get R is equal to 15,000 divided by 2000. This is going to give us $7.5 per pie. So we need to sell at $7.5 per pie to get a profit of 5,000 and we can sell 2,000 units. So that's the problem. So this concludes my lecture on cost volume analysis. Thank you.